We are live. All right. No, we have more intros to do.
Yeah. We went live for Peter. That's what
Okay, Peter. You can call me guys Peter because he's here. Been involved for about a year. As I mentioned many times, it's a great playground for the decentralized tech. Making
We are
all work
live.
together. Enjoy this art.
All right. No, we have more intros to do.
Yeah.
We went live for
I'm
Peter.
Daniel.
Okay,
I'm in the Mesh.
Peter.
And
Okay, Peter.
I do
Because
stuff.
he's here.
I'm gonna do the presentation
Been
later.
involved for about a year.
Alright, so
As I mentioned many times,
we're
it's
going to do
a great playground for the decentralized tech. Making
We are
all work
live.
together.
tool
Enjoy this
that
art.
Daniel, Marg, Andrew, and
No, we have more intros to do.
Yeah.
We went live for
I'm
Peter.
Daniel.
Okay,
I'm in the Mesh.
Peter. Okay, Peter.
Presentation.
What's Corpot is in a nutshell? It's like automated diagnosis.
Many times, it's a great playground for the decentralized tech.
We are
All
live.
work together.
And there's an issue, and the idea is that
No,
send an automated process where
We went live.
I'm Daniel.
they hit the button and
I'm in the Mesh.
right there, and it's sort of how you do it.
Presentation.
And what's Corpot is in a nutshell? It's like automated diagnosis.
Many times, it's a great playground for the decentralized tech.
And
All work together.
there's an issue, and the idea is that send an automated process where
We went live.
I'm Daniel.
they hit the button and
I'm in the Mesh.
right there, and it's sort of how you do it.
Presentation.
And what's Corpot is in a nutshell? It's like automated diagnosis.
Many times, it's a great playground for the decentralized tech. All work together.
And the idea is that send an automated process where
We went live.
I'm Daniel.
they hit the button and
I'm in the Mesh.
right there, and it's sort of how you do it.
Presentation.
And what's Corpot is in a nutshell? It's like automated diagnosis.
Many times, it's a great playground for the decentralized tech. All work together.
I'm Daniel. I'm in the Mesh.
And it gives them the option right there. And we actually even do a step where we try and auto detect it. So in case they don't know it, we look it up using either their Slack email or their name in Slack, or even if they have it in the metadata in their profile. Though if they have it in the metadata in their profile, they probably know it. So, but email actually comes up to a pretty reliable way to do it because most folks sign up for the Mesh and for Slack with the same email.
and this field will also take install number. So if they don't know what an install number is versus a node number, it'll figure it out and then print the node number in the response.
Yeah, and so because you could always convert a node number or an install number to a network number, right? And then the other flow, wait, go back. The other flow is on any mesh. I think we do it based on any message anywhere within Slack, right?
Anyone that we haven't
Yeah.
added the bot to.
Right. You can sort of select any message and select run node diagnostics, and it will give you the option to like, hey, it looks like you're trying to run diagnostics on somebody's message. So even if somebody pops into like a hub channel or something, right? Here we can do this.
Cool. Just an example. So the person problem, the support bot, which is one. And we'll do a live demo to kind of present it. Cool. Database client. So just like some technical details of how it works. We have this spreadsheet, and the database client does a lot of things to look up node numbers, and you can convert different things back and forth. So this is just an example of some of the commands we do. The actual script is pretty long. Daniel mostly wrote all this stuff because it involves kind of intimate knowledge of the actual workings of the network. But kind of in summary, it does some IP parsing to figure out what the node number should be. And the IP does a ping to see if we can connect at all. Then it looks up the Omni interfaces, does a speed test, and also gets some stats from the OS.
And you can kind of see an example of a network, like a report here, right? So you can see it like grabs the text is a little hard to read here, but it puts their network number in there, but also the IP address of their Omni, and then also the trace route that shows what that connection looks like, as well as this is an output from the Omni itself showing like the status of all the interfaces, and so you get like all that nice nice configuration information like what's going on at this node, like just right there in the thread, as well as a speed test, which is like super helpful for performance stuff. And then we actually query UISP. You get a list of devices that are at that network number and their performance as well. And Daniel, did you want to talk a little bit about this one? And like, this is the one where you looked at this, actually literally this diagnostic report, and you were like, something's wrong.
Yeah, so, yes, guest star here. So basically, the person had requested on Slack saying that their internet was slow to unusable, typical whatever. And normally when someone says that, you have to log into a few different interfaces to figure out what it is. But since their message triggered this being generated automatically, right? All I had to do was look at this and say, okay, speed test, bad, 1 megabit, clearly there's an issue. Look at the trace route on the left, and you can say, like, why is it going through so many hops? That doesn't make sense. So that immediately you have that information. And then I look down and I can actually see on Omni, if you look at the number 5, or number 4, where it says LBE, you can see that that's missing an R. R means running, and if there's no R, it's not running. So then the only thing I had to do, instead of logging into UISP or logging into getting the spreadsheet or figuring out some other nonsense, I just logged into Omni, did a PoE power cycle, and that was it. Done. 5 minutes.
Is there any way to, with the report, automatically flag parts of it that might be problematic? So a speed test under whatever our minimum is gets flagged in red. If there are 15 hops, they all get flagged. If something, programmatically assessing problems and then flagging them.
Yeah, that's totally something we're looking to do in the future.
Okay.
Yes, absolutely. Yeah. Because there's definitely a lot you can do with like common problems.
Got it.
Yep.
Okay.
Yeah, and then like Daniel was saying, he rebooted it by power cycling the PoE port, and they were able to get it fixed. It's great.
Quick question.
Yeah.
When you were, one further back, I see that the station and signal, like the UISP stacks, have downlink and uplink pretty happy. And so what do those numbers represent if they're not the connection with the light beam?
So I'll chime in here, and this is something that someone had brought up, probably Olivier, is that right now, basically the reason why UISP stats shows up is because we're pulling those things. What I think is happening is that's showing the last known stats. And we also need to get the offline outage flag as well.
Sure.
So that will be the next thing.
Yeah, there's definitely got some more information there. Yeah, go ahead.
Can this script be programmed to power cycle interface, or that's something that we have to log in manually?
So at this time, all of the sort of the proactive like actions that are taken are done manually by volunteers. That is an interesting suggestion of like, could we integrate, like maybe you could have like buttons in the thread for the volunteer to click like, oh, power cycle LBE or something. You want to be a little careful with like safety so that people aren't like just randomly power cycling stuff. But I think there's definitely room to explore there. Yeah.
Are we at the question section for this?
I mean, we can take questions throughout. Yeah, no worries.
Is there any reason why we need their permission to run this diagnostic? Can we run it on every request?
Yeah, so like kind of logging all that data. I think that's like another cool project that's related to it. We kind of just wanted to get something working, which is
great.
But yeah, I think that's definitely.
Could we even start running it automatically, even with people who haven't submitted requests, just to clear that? Okay.
And I mean, a lot. USP actually has a lot of that those stats, and that's already recording. So it's just a matter of like interfacing with that.
And maybe just keep a historical log of everything so you can know when to come.
Yeah, that kind of thing is definitely something as far as like support goes. It'd be very, very useful to have historical stats for the omnis. Yeah.
It also might be good to have stats for positive experiences. So we know when people are
Sure.
satisfied.
Cool. Okay, so we're going to show a demo now. So this is Slack. This is the support channel where someone would go in and have problems. So it's like, ooh. So right away, this whisper. This is called a whisper in Slack, or an ephemeral notification. That's only shown to the member who has a problem. So they can either run the report, or if it's Brian or someone just posting something else, they can ignore it. And then the report, it pops up a dialog box. If they had their node number in their Slack or any of those other things, it would automatically load it here, so they could just click submit. But in our case, what was Daniel's number?
5107.
5107.
This is an example. Oh my goodness. Okay, so right away the bot responds, and it's parsed the node number. If it was the install number, it would also still show the node number. And if we want, we can click a map and kind of see where the problem's happening. Not to dox Daniel. And in the background, it's running all those scripts. So some of them, like speed tests, actually take like 30 seconds. So eventually those will show up.
Maybe we could edit the comment to say that it might take 30 seconds.
Yeah.
We played around. We had some original language. So we used to run it sort of on every request automatically. So we played around with this a little bit. I think ultimately, because it's less than a minute, it's it shows up eventually and everybody's happy. But yeah, we can play around a little bit with some of the language.
Yeah, I just think we have to remember we're dealing with much less technical users who are having as much information as possible when they might have less internet than they're expecting, and
And I second that only because I'm impatient. I might not stick around for a minute.
people are smart, but are not all smart at gamers.
And maybe we could also do something where like some of these pop up before others. Maybe we could run the ping first, for example. Cool, so this is the output of stats. We kind of went back and forth a little bit to just like figure out what should be shown, because it's kind of like limited resources when it's collapsed. But at the minimum, it shows the IP and the node number, and then you can expand it, you get the ping, and basically all the things we discussed in the previous slides.
Peter wants to ask a question.
Let's say I'm responding to a ticket from a ticketing system. Can I just DM the bot to give me the stats instead of looking around?
Yeah, so what we've been doing for that for now is we have like the support bot test channel, and then you can just make a thread there, and then put the. It's a little bit hacky, but it works pretty well, right? But yeah, we can definitely set up something where you can like DM the bot. That's totally features able to do that. Yeah. So you can do the same thing, just with your own message in a different channel. Yeah. And what's nice about support bot test is like you can share it easily with other volunteers. So maybe that's one reason to keep it there. Yeah.
And that's kind of like a cool advantage of doing this in Slack that we just get for free. Basically, there's a log of everything that happens, and anyone can see it.
Yeah.
Have you integrated this or talked about integrating this with OS Ticket, our support ticketing system?
I think that could be cool. Yeah, I'm
You
not
run the
sure.
same script and then put it in the thread there. Yeah.
It's pretty easy to integrate the API script.
Yeah.
It's pretty cool.
You said you're making it available. Based on what I'm seeing, somebody else could go in and potentially grab personal information from a previous help request. Is there any way we can obscure that once it's been resolved so that if it's not your ticket, you won't get to see it?
Yeah, so currently on the support channel, it's kind of just all public, so whether you're doing it kind of automatically or not, it would be shown. I think maybe that's like a different conversation, but
Yeah, so the only information, if you want to go back to one of the reports, the only information in this report that is like even remotely identifiable is their network number, right? And that's kind of like what was happening before when people were requesting support, was like the first thing the volunteer would do would be to look them up in the spreadsheet and put their network number in the thread. Right? So as far as information security, like this is no different than what we had before. Doesn't mean what we had before was correct, but like this is basically the same thing. It doesn't change that. Yeah. Right, like the performance statistics for some random omni somewhere, like that's not relevant or sensitive to anything.
Okay, they didn't get to read the whole thing.
Yeah.
So.
No, yeah, there's not, their address isn't in here or anything like that.
Good.
Yeah.
The only thing that is the IP and their Slack link.
Right, but the IP is derived from the network number, right? Like it's all, yeah. Okay. Oh yeah, so this is kind of how it works. Oh yeah, wow, that text is horrible. So right, the basic idea is that you have Slack as sort of the interface to the member, right? They're working and they're able to send a message, and they do some interaction, and then we use the Bolt SDK for Slack, which is this really cool, like they have one for Python and JavaScript too, I think. And basically you like just set this running somewhere, and it like opens a long-lived TCP socket with the Slack API, so you actually don't even have to like open any ports or anything because the WebSocket connection actually originates from our server, and we just leave that open, and then they can come talk to us and send us messages in this sort of connection we opened. And then the SDK enables like all of the sort of parsing and stuff and all the connections. But all you have to do is just like register functions in Python that it can call. And then what we do is, from that Python code, we can have all kinds of custom logic, including things like going out to Google Sheets to look up the network number, and then doing like a sub-process call to call the bash script. And then in the bash script, of course, we can SSH into the Omni because this is all running on Daniel's server at SM3 instead of a Docker container. And so we have access to the Mesh IP space, and we can go into an Omni, or we can use the, what is this called? The Mesh, NYC Mesh tool.
Yeah, so Gabe, he's another volunteer. He wrote a tool actually that lets you query UISP in like a easier method, easier syntax. And so we use that in our tool.
Have you on your security hash and make sure to validate user input? So it looks like the chain of user input to root directly.
Nice.
Well, that's a good point. I believe we do like a cast to integer in there, so that should be relatively.
Yeah.
The only user input we take is the.
Yeah, the only input to the script is the directory.
Yeah.
Could we hash it instead, maybe? Or would that?
Why? It's a
With
number.
the node number, so I think it's more likely to stay.
That's a good point. Thank you. We'll make sure that we're thinking carefully about that attack.
There's an online resource called Big List of Naughty Stream. That's a test.
So I just wanted to talk a little bit about like some of the things we learned from this project and like that are generalizable to mesh projects in general. So like the initial pitch for this, it was like we were talking to Marg about like, oh, wouldn't it be so cool if we had a troubleshooting tree bot where like people could say like, oh, I'm having this issue, and it would ask them questions like, oh, have you tried this, have you tried that, try doing that. And what we kind of realized is that like one, that actually wouldn't like provide all that much value. The kinds of problems that happen on the mesh are not sort of like easily resolvable by the end users. And two, like even if you could figure out a way to do that, the scope would be just too big to get value quickly. And so we were worried like, oh, we're just going to go and we're going to develop this thing for months and months and months, and nothing's going to come of it. So we tried to like focus in and just keep the scope as extremely narrow as we could, just to like try and give something that's valuable to the mesh as quickly as possible. And so that was where we sort of narrowed from like, oh, this general, it can help with everything, to like, no, just this one, like, let's ease this volunteer pain point. Let's start with this thing and then we can branch out, right? So now we're thinking about like, how can we do this on an ongoing basis, how we can get interactivity, or rain notifications is one, or we can get to this in the next slide, but like, a lot of support requests come in when we get heavy rain. And so like, we'd love to have a mode of the support bot where it can say like, oh, thank you for contacting us. There's heavy rain right now. That's probably why you're having problems. Right? Something along those lines.
Another thing that we learned, which was really cool, like having 4 people on the project was really nice because there's always someone reminding us to get back to work. Like if we just got bored of it or whatever. And so I definitely like stopped working on it for 30 cars or ended it.
Yeah.
But because we had those
and I see Andy was like putting commits in their GitHub. I was like, oh, I should get back to that.
So like related to the commits, one thing we kind of learned was that it's really important to share all the credentials. So this is kind of a list of all the random things that we use, and kind of like everyone on the team needed to have these, or like things would get caught up. And some of them are obviously things that only like admins would have, but just thinking about those at a time. Oh yeah, and so the Mesh Center, Oliver has an app that he's working on called Mesh Center, which is kind of like some sort of unified thing that can partially replace the spreadsheet database that has all the member information. And that could potentially actually like eliminate a lot of these things, because then we wouldn't have to use Google, and the identity of the person would just kind of be known because it's all in that central system. So
Yeah, we could use sort of one key for a bunch of this stuff, or the mesh center key would simplify that access. Yeah, so like, these are some steps we thought of for a couple in the room here. So like, yeah, these sort of rain/maintenance mode, right? Like if we need to take a hub down for some reason, being able to turn on support bot mode so that people can get notifications right away. They're like, hey, I'm having a problem, like, oh, we're doing maintenance, like that's probably it. Or even like, oh no, someone misconfigured something and the whole mesh is down, right? Like being able to flip something on so that it's, so the volunteers can focus on fixing the problem and not answering the people who have the problem, right? Or even things like suggestions based on the detected failures, right? Like there are some things that are pretty easy to detect, and you can just say like, oh, okay, you're supposed to have an LBE, but we can't see it. Maybe try power cycling Yami or something, right, to sort of reset everything. Or even trying to bridge on the interactivity, right? Like sometimes people can show up with like, oh, I don't see the Wi-Fi network on my phone, right? And that's a very different situation than, oh, my internet is slow, right? It's just some of those situations might have some interactive, like, okay, you could try power cycling the TP-Link, you could try power cycling the Omni, just to try to take some of the load off of the volunteers.
Yeah, another feature that could be cool related to that mesh center idea is visual traceroute. So we already have a traceroute that has a list of the IPs and node numbers. So we just have to make some small changes to the map, and then we could basically show all that information in a cool visual way. So if someone wasn't just familiar with the mesh, would be able to kind of map everything. Some more random ideas. I think someone mentioned this, device performance history, so pulling in some of those UISP statistics, making them more accessible.
Another thing we could try and do, right, is we have pretty good historical data for all of the Ubiquity gear right now, because sort of UISP collects that centrally. We don't have such a great centralized repository for the microtik data. And so trying to sort of build up that repository, and this sounds like there's a project ongoing to try to get some, like a Grafana server set up that we could log performance statistics from the Omnis too.
And there already are like a number of Grafanas set up, so it's just a matter of kind of adding to what's already set up. And then rudimentary ticket features, so it could be cool if we recorded some information about like who's making a ticket, or if the ticket was actually resolved or not. Because then we could have like a cool list of like, you solved all these tickets, or there's still like 10 outstanding tickets where people never got their issue solved.
Right, or like we could have statistics that we could put in brochures or something like, oh, we respond to cases, and time to first response for our cases is like 10 minutes on average, or 5 minutes on average, or whatever it is, right? Like to have some metrics on that are like, oh, look at how that's changing over time. Some of that data could be really useful in terms of like prioritizing support of the project or advertising it.
Both have 167 times quicker than Verizon.
Cool. So if you want to help us work on support bot, we'd love you to help us. And there is a Mesh services channel where people kind of discuss all the different services that they have. And the repo is listed here, and it's all open source, so you can see how it works and do your own thing. Mesh Center. So like that's an ongoing project, and if anyone wants to help with that, I think Oliver will also like support that. Cool, and that's it.
Great.
Any last minute questions? We kind of did it throughout, so. Cool.
Thank you.
I guess while we wait, I will say that when I saw the topic, I was like, okay, it's going to be kind of a tree thing that does this and everything. I kind of had this vision in my head, and that was a much more useful and much more, like progressive choice of way to go with that. I love it.
And that's where we started too, right? Like we started in the same spot. We're like, oh, we know what a support bot is. Let's make that. And it's like, wait, no. Let's make the thing that's useful and helpful. And, yeah.
It's going away. So they
Most of them are on the right.
You're doing fiber splicing.
Yeah, oh.
but it kind of goes back and forth. Good evening, everyone. I'm Daniel. Yes, so more thorough intro. A lot of you know me. Volunteer in the Mesh Org since 2020, doing some stuff. And I'll first, before I even talk about what this is, I mean, the main topic of this is some of the big scale upgrades we've been doing out of all of our hubs to really try to improve quality of service for our hundreds of members. And, and I want to just mention, I'm going to try and not make it too techy. Feel free to ask me questions. I'm happy to answer. But also that most of this, I had no idea how it worked when I started Mesh. Not one clue. Fiber, didn't know anything about it. Routing, didn't know anything about it. Nothing. So you can be an expert if you spend late nights climbing on the tops. With that said, let's go into it. So in the past couple months, we've been doing some big upgrades to a lot of our backhaul links in the network. Do you want to share? We've been doing a lot of big upgrades to the backhaul, to a lot of our big hubs to try to, improve quality of service to all the members and to try to make some bigger changes for everyone. I'll start with a little bit of background. A lot of people see the mesh and they ask, what is the mesh? And I'll try to keep the detail lower. I'm using a paper drawing that was drawn by Andrew because I thought it was good to illustrate, what are the different kinds of links that exist? There are links that make up, there are multiple kinds of links that make up parts of the mesh. And some of them are higher capacity. Some of them are, lower capacity. Some of them are really designed for, hub to a node or like a particular apartment or something like that. But some of them, are able to handle many things, and we allocate different, we allocate certain kinds of equipment for certain needs. Some links as well, some types of links may be good for some cases, but we know that they have limitations, such as, if it's a really long link, we may not be able to use some of the more fancy, high-tech, fast stuff because every time it rains or drizzles, it goes out. So this is all part of the planning for how we figure out what infrastructure we use. So all I'm talking about today is not regarding light beams or apartments or hubs. All I'm talking about is the backbone. And the backbone is essentially all of our high capacity links, all of the links that transmit from hub to hub, possibly carrying hundreds of members of traffic at once. These are the links that are connecting all the different parts of the mesh, maybe even crossing rivers, crossing various neighborhoods, and basically our goal is to try to figure out how do we optimize them so they can carry the most amount of bandwidth and be the most reliable at the same time. So for a type of link to be that, we want to make sure that it can, A, have a guaranteed capacity, meaning that it's not going to randomly change how much bandwidth it can carry from one day to another due to interference. Like we know if that's a gigabit link, that's a gigabit link. And we don't got to worry about it, unless if it rains, but we'll get there later on. This is our ideal conditions. We also need to make sure it can handle multiple hubs, right? Sometimes there are various things that happen. Building gets built and blocks a link, or the power goes out somewhere. Making sure that all of our backbone links can suddenly handle a surge of traffic coming from somewhere completely different. We want to make sure that all of our backbone links are able to do that. So that is another criteria. As well as to make sure that, and this is more in sort of the setup on how we configure them, making sure that they're prioritized. So that's essentially making sure that when we do our network planning, we're making sure that, in cases of non-ideal conditions, those backbone links are going to be used first, rather than trying to go through some person's apartment, because that could be a bottleneck. So, here's a little bit of the backstory. So, Vernon, right? Vernon is cool. It's a 26-story building in Bed-Stuy. And basically, at one point in time, and for most of Mesh's history, the Mesh was kind of two separate meshes. We had kind of like a Manhattan, Greenpoint kind of mesh, and then we had the rest of Brooklyn. And they were logically connected through a virtual network. So the super nodes where the internet comes from, they were logically connected, meaning that like if someone was hosting like a file server in Manhattan, someone in Brooklyn could still get access to it because they were logically connected. But there was no over-the-air links that were actually linking, crossing the East River down to North Brooklyn, South Brooklyn. That didn't exist yet. Then Vernon happened. This created a lot of opportunities because now we can actually create, as part of our backbone network, we can bridge the two sides of the mesh together, and that increases our resiliency. If something happens at SN1, now we have the option to send all Manhattan through across the East River to Vernon and get down through South Brooklyn. So that's what we need to do. In order to take advantage of that, we need to make sure that the links are able to take advantage of that capacity, so we get to meet all of the criteria of the backbone, the guaranteed uptime. You need to carry multiple hubs in case something happens, as well to make sure that that's prioritized over any other weird links that may pop up. So the previous state of affairs, yes, the text is hard to read, but I'll summarize. Basically, all of the blue links are like, is the demand. I'm not explaining it great. Basically, all the stuff on the left is what is all the members' traffic. All these people, these are the sectors. These are point-to-points to various hubs in Brooklyn. And all of those are people who are going to be downloading traffic. Those are all going to people's apartments, to condos, to co-ops. Those are all getting, that's where the demand is coming from. This is how it was before we started the big upgrade project. They all go to one big switch. There is one fiber cable that goes down to the router, and that basically then gets sent out, depending on how we configure it. For previously, we had two antennas. On the right here, we have a fancy new 10 gigabit link that goes to Green Street. And we had a 1 gigabit link that connected to SN3. So for some context, what that means, so if this is in the middle of Bed-Stuy, we had one high capacity link going to here, literally next door to here, the tall building. And then another high capacity link that went from Bed-Stuy to Sunset Park, just so you have that set in mind. Now the issue with the link to Sunset Park is that the type of antenna that we're using was not really equipped for that long distance. That's almost 7 kilometers. And this is when I talk about like having to, when we are planning it out, we have to balance performance and resiliency. It's so long. Every time it would drizzle, or like it would just go out. So constantly we had to implement like failovers and other weird networking stuff just to accommodate this bad link that just every time it rained, it went down. So we needed to do something about it. So over the past month or 2 months or so, we undertook a pretty big project. Rob here is featured, where we basically improved the infrastructure at a few of our major hubs. Pretty much the ones that we did the most work at was, we're doing the most amount of work at Vernon and SN3. So Vernon was the big job here. So since we only had one fiber going up to the roof from where all the equipment was, we weren't able to run any more antennas. Now, in the pixelated, you can actually see we're running multiple stranded fiber up to the roof. That means we're able to multiple high performance, high capacity links to the roof. We can put multiple super fast antennas on the roof now, meaning that we are able to rapidly scale, and it's modular. We are not going to be limited by limitations of equipment, because now here, that's going to be future-proof for like the next few years or so. We don't have to worry about it. We have that extra capacity. Similar to that, these fibers come down into the radio room. We have a fancy new router that can accommodate that, instead of having to share just one link. Because, the mesh doesn't use that much traffic yet, but we're already creeping up there. especially after Vernon, which is now one of the most heavily trafficked hubs in the entire mesh. It uses even more than Supernode 1. You know, we need to make sure that we're prepared to handle the traffic that comes in. So that's why we're future-proofed in that. And on the other side, you can see, it's a little hard to see, but this huge dish is a new type of, it's a new kind of radio that we're doing more. It's more like gigabit plus links that it needs fiber to take advantage of all the capacity. But basically what it means, it's able to travel that 7 kilometers way more than the other dishes on the right. Like these were old ones, these were the big ones. It's twice as big, but it's pretty big. So now the results. Here's a little bit of diagram. So now the yellow is fiber. So we now have a big fiber, multiple strands of fiber going up to a box, which connects to the 2 high-capacity links that we have to Sunset Park and to Grand Street, which is here. So it's all the same kinds of antennas on the left. We did add a sector for testing here, but essentially the idea is that now we are able to have much more stronger, dedicated connections to all of our backbone areas. So we're no longer sharing or putting 2 antennas on one pipe. They get their own fiber, they get their own link, and now that allows us to scale up. So, in the future, when we put new antennas at Vernon, let's say, if we had some other partnership, like let's say we had an antenna at Elmhurst Hospital, for instance. We want to do a link from Vernon up into deeper in Queens. Now we're able to do that because we are able to put more capacity, more antennas to do that work. Before, we would not be able to. So the future of all of this techie planning is that, we definitely have to consider what the options are. It's always fun and games to add as many antennas as we can, but at a certain point, it becomes unpractical. We want to start figuring out how we can take advantage of some new technologies. I took a little screenshot from Ubiquity's page on some of the point and multi-point stuff they have, which is basically antennas that are both high capacity and they can go to multiple hubs at the same time. And all you need is one antenna at the hub. So instead of having a whole pole full of stuff, you could just have a couple of antennas that cover a wide area, like our regular sector antennas. We also have to figure out how, this is still to this day an unanswered question. How do we balance more antennas and power demands? Some of our equipment that are at all of our hubs simply do not have enough ports on them. Like they have 16 of them. That's it. What are we going to do once we need more than 16 antennas on the roof? We haven't got there yet, but at Vernon and Saratoga, I think there's one more port, one more antenna. Uh-oh. So that's something we have to think about soon. And as well as, and the last thing is just making sure that we're really balancing capacity and reliability. The thing is, everyone is going to want the fastest speeds possible. Everyone's so interested in gigabit. Everyone wants, zero ping for their gaming and for their streaming and all this and that, right? It doesn't matter if when it rains, it goes out. Because that's a Zoom getting interrupted. That's that's a class getting cut off. That is, telehealth being interrupted. We have to make sure that this is resilient. And the downfall of a lot of the new technologies that are coming out is that they're not really thinking about reliability. So the next thing that we want to consider is how do we make sure we implement the technology in a responsible manner that will stay up during the rain, during hurricane, tropical storm type weather, so that no matter what's going on, people will be able to stay connected. And that's my presentation. Thank you.
What internal factors, not like rain, is the most affecting of reliability?
It's
What
rain.
one problem? Sorry?
It's raining. That's it.
Yes, but we can't solve the rain. So what one issue could we solve that would be the most impactful for getting the number of nines of reliability that we want?
Power outages.
Yeah, that's a great question. So the thing is, and so the answer is that I don't have the answer. Okay. And I'll explain why I don't have an answer, and that will give you the frame. When the mesh started, 60 gigahertz didn't exist. That was still a fever dream at some grad school. Seriously, like millimeter wave just wasn't a thing, except for the military uses or some other stuff. So in that regard, you know, the mesh was using lower frequency stuff. So that's like 5 gigahertz, Wi-Fi band, which is not affected by the ring. 24 gigahertz, which is somewhat affected by the rain, but you know, in some circumstances it could be a little bit better than millimeter wave. And you know, so rain was not that big of a deal. In the beginning, you know, earlier in the mesh, like when I started, more often what we see is rain would affect, you know, badly done installs. Like honestly, like let's say the light beam wasn't securely mounted to the pole, it rips off. Okay, that's a support visit. Now it seems like we've been getting better in that regard. We're not really getting a lot of callbacks now, which is great. But the big issue is that, you know, the bigger issue is that now that we're going to these more higher frequency waves, they're really susceptible to it. Now that we have, at the same time, now that we have so many more members on all of our hubs, we need more bandwidth. Some of the antennas that we were using 2 to 3 years ago between, you know, PH and SN3 and all these things, now they simply cannot handle the traffic. They're already, like, the antenna that we had between Vernon and SN3, which is from Bed-Stuy to Sunset Park, it was oversaturated already. Like, we upgraded it twice, and it was still getting oversaturated. So now we're here where we have this fancy new 10 gig link, but it goes out in the grid. So that's the question. How do we solve that problem?
What is the cost effectiveness and work effectiveness of using multiple lower layer 24 gig type antennas, like gang together, all pointed, I don't know, generally in the same direction, maybe bouncing off different repeaters to get there? Is that more expensive, less expensive? How much extra time would that need?
I think that's a great suggestion, honestly, because that you know, let's say if we did link aggregation on 2 AF24s, that might make sense. They are very pricey. They're actually more expensive than the new stuff. But even, you know, cost is not, well, we have a bunch of them sitting in the mesh room because we decommissioned them to upgrade them with something that's less reliable. So I think it would be a cool experiment, and maybe that's something we can try.
I mean, one way to fight the rain is to decrease the distance. So filling in the space between two supernodes, if you have a supernode in between the two supernodes, you're going to have better reliability in rain than you would otherwise. Instead of all of them SN3 Vernon, you hit somewhere twice in between, you're going to do better. That's just nothing.
Yeah, or maybe not a supernode in the middle, but just you've got a dish pointing this way and a dish pointing the other way, and it's just a repeater and nothing else.
Right, so that's a good point as well. You know, I think there's two things, right? We see that in Manhattan more often. Like if you look at a, I don't know if this is super feasible. No. If you just look at like the makeup of like the map, you'll notice something that's I always thought is interesting. In Manhattan, you have a lot more hubs. Those are all high capacity links between the hubs for the most part. And the rain issues in Manhattan are almost non-existent. Because they're so close, because they're all underneath a kilometer. They're all well within the rated range for these antennas. In Brooklyn, where are the blue dots? So this is a problem, right? Because in Brooklyn, we're relying way more on select tall buildings in the neighborhood, not so many local neighborhood hubs. We've made, I've tried, you know, we've made some effort, you know, in the Bed-Stuy area, you know, there's a couple ones here and there, but there's also an administrative cost, you know, time cost of then trying to figure out which nodes can be moved to those smaller hubs, and making sure that if those smaller hubs, it's not really, if they're renters, can you put so much equipment on a roof and then they move out and then they're screwed? There's just a little bit more social problems that we deal with, less than infrastructure in Brooklyn.
Do we have information on the social problems so that we can map them and figure out how to work around them?
It's less about that. It's just that the climate is that, the people, just in general, the people in Manhattan who don't generously given them roof space are usually owners.
Okay.
It's just not the same. It just isn't.
One reason there's so many hubs in downtown is through working through one management company that owns eight buildings.
Yeah.
Sorry, the lowest distance between the height of a building you consider as in Brooklyn to minimize space between hub and hub. What would be the lowest height distance for it to work?
Yeah, I mean, height is okay. It's just the line of sight. Line of sight is very important.
From
Yeah,
Greenwood?
it's got to see it, right? So the issue is that since there's not so many super tall buildings in Brooklyn, even if a tree is in the way, you're screwed. So it's just got to see. If you can see it, if there were a building, I could see Vernon, I could see SM3. Yeah, you can hook it up. It's just, there's just not. Yeah, it's roughly.
A lot of things in Brooklyn are like 6 floors, right?
Exactly.
So you get like 10. And,
It's just needs to be higher.
So my next question is, if it's 6 feet high, maybe 7 feet in total, on top of the buildings, are you looking at an extension when it becomes higher?
only up to a little bit, like 10 or 20 feet max.
That would be the code.
Code's 10 feet.
Yeah, you can't do
6
much.
feet. 6 feet.
Really?
Yeah. You're much better off getting a taller building.
Okay, understood.
Yes.
Is there a list, is there a list of buildings that you want to build on, that they want to put equipment on? That would be probably not buildings, appropriate buildings that but maybe if there were buildings that you had your eye on, and you would need great nodes.
Where's the minutes?
Several nodes, like it'd be kind of cool to have a list of that.
Targeted advertising.
No, it would be, yeah, exactly, it's like, it could be advertising or a list, and then if anyone has any hints with these big buildings,
Yeah.
it would at least be something where they get preferential treatment in exchange for solving our issues.
Sure.
Just talk to them in person.
Yeah.
So here's the main caveat, right? And the traditional mesh fashion is that there are cases where I think we approach people, as Brian says, approach a management company that is, let's say they want rooftop Wi-Fi on all of their, level. It's that there is a big labor cost in actually doing it. The list is easy, right? That's a DOB outreach. That's very expensive. And I think, I will, maybe this is not such a gratuitous thing to say, but I think my time in Mesh, it's very easy to.
Hey, Daniel,
The successful projects.
open the mic on your laptop, please, for the screen share. Can you open your mic? Thank you.
Okay. Good. Okay. Yes. Okay. Thank you. A lot. Some of the more successful projects in the mesh are the things that give you that instant gratification. Oh, we put an antenna on the roof. Oh yeah, we connected to 10 gig. Oh yeah, we put omnis on the whole block. Oh yeah, we spent 6 months going back and forth with a management company that ultimately doesn't want us on the roof. It's tough. So.
Some people like that kind of stuff. Like, there are a list of 3 rooftops,
Mhm.
and the people who look at them, and one person said, oh, I know.
I think that's
Yeah, that's a great suggestion. That's great. Yeah.
Or targeted people advertising, did they do property owners in area?
So I was joking with someone else about this, but I'm like, I work for the government, and it's like the amount of emails I get from lobbyists. I'm like, we should just hire lobbyists.
And there is a Hubs Slack channel, so if you have a candidate, that's the place to put it. Right?
Yeah. And I think a lot of it is like, there are people on the mesh who actually do live in nice buildings. It's less that we don't have access to buildings. It's just I'm nervous because, like, I'll tell you, one of our hubs, and I'll just stop the screen share for now, and I think the call is about to end. It's just that a lot more people, you don't have a lot of owners in Brooklyn, especially in those like larger 6-story multiple occupancy. So if they're moving and in that time that they've had to install, you haven't gotten buy-in from your other neighbors, you're gonna have expensive equipment on the roof that you don't have access to, and that's a risk.
Yeah, I don't want to. We're consider conversation.
That's why I'm saying I don't have the exact list of multiple things.
Yeah. And there's like 10 people or 50 people who all are keeping the list in their head.
Those are things that we add, we may have a buy-in.
What I would need is to give me a 10-block radius. And we can go from there.
We use like Google Maps to map the addresses of specific buildings.
Yeah, we could, I mean, the DOB will literally print out something. If you email them, I need this, boom, open, NYC open that, like, it's there, that's already there. It's that. This is how we do it. Actually, Tony, some of you know Ian. He has a friend who has a big contract with Nitro to do solar. And
Hey.
I went and site survey to the Queens Bridge.
Daniel, can you rejoin that call? I'm on laptop audio, so it really can't hear you from over there. Sorry.
Yes, Queensbridge houses. And so the thing is that the thing with the Queensbridge houses is like, okay, we can partner with these large companies, and maybe they have things, but I think they're the people that they're trying to serve. At least, it's not really towering park style building. It's more like a low level development, so it doesn't help. It's not as helpful as it could be, but that is a good point. And I think if we had more engagement for the outreach kinds of things,
I'll also just jump in that since NYCHA came up, we've had a complicated relationship with NYCHA where we are on pretty good terms, but they have a lot more sort of due diligence requirements with their buildings because they're like effectively the biggest management company in the city, and so they've got like engineers on staff and things like that. And they've been very good, and we're kind of stepping back and forth about a few things right now about some more buildings that I think will work out okay. But in Brooklyn, like outside of Manhattan, NYCHA buildings tend to be the most prominent buildings outside of maybe like special kinds of low-income co-op buildings. And so there's a lot of potential, but there's also a lot of like reason to not play it super fast and loose with NYCHA, as opposed to some other like, let's say like a single co-op building or a single rental building where he's noticing that you put something on the roof and the tenant is okay with it, and so like you'll put up some antennas and be willing to take a risk there, and there's a reason to be maybe more protective of that relationship. I don't know that we've
but I think it means that there's like from Vernon, the tallest buildings you can see to the south is the NYCHA building, and we've talked to them about it, and they say, let's do it. Let's get some plans going. Also, by the way, the building is getting turned into something called Brad and Pack, which is like a whole property transfer thing. Like then it becomes complicated, and so that means that the opportunities for those are hard, but those are also some of the choices buildings. And so there's like a big risk reward ratio thing going on. For what it's worth, we've engaged with an architecture firm that has made plans for us, and I think right now there's a question about maybe sign up for some insurance things. Like there's also the question that because we need plans that are signed by an architect to engage with NYCHA, we need a qualified architect, and that really is about insurance and professional liability and stuff, and so that becomes complicated. Well, it's a little. I mean, it's pretty far along right now. We already have plans from someone, but you know, also, frankly, architects are hesitant to engage with sort of volunteer labor group. And so that adds another level of sort of complexity and kind of sensitivity.
Well, someone asked about height, and your answer was height doesn't matter, it's just line of sight. So then, I know, I mean, there's tons of 6 to 10 story buildings developed all over Brooklyn.
Yeah, for that specific goal of creating repeater units. Like, you know, and that's a suggestion I didn't think of. So like, yes, normally we're looking for like a proper hub where nodes can connect, but like straight up man in the middle kind of thing to solve the range problems.
And the other reason is making sure you get free access without being restricted.
Exactly. So that's it. It helps with that person if you're giving internet to someone there. So, you know.
But there are, I would guess somewhere in the mesh there are small-time landlords, right? That like we're on their roof and they're pretty friendly with us, and so like it wouldn't be a situation where we'd be kicked out next year, right? Like, that would be a really interesting strategy for a repeater.
That's the new idea.
Yeah.
How does the religious organization that owns the properties, they've been there for a long time, and they can offer internet to the congregation, as well as the new idea with date?
I'll clarify. That's a new idea. Because we already have, I do know property owners here that I've installed for, and others I've installed. I think it makes sense. Like, they're, you know, I've installed for a church before. It's like, yeah, it's cool. It's just a matter of implementing it.
Very well acquainted with a lot of mosques in Brooklyn, all over Brooklyn. That discussion needs to be on.
I think it's non-residential installs generally. I got a question about. I remember there was a time when I first, like very early on in that, it felt like Saratoga was our cool Brooklyn thing, and it was kind of full. Like, oh, we're still adding things to Saratoga and slowing everyone down. Uh-oh. Is that? I don't know. And I would be curious if like Vernon is there. Is Saratoga still there? I know we've approved both of them. Are they doing better? And was that more about the sectors and having changed out the sectors has improved it, or is that about the backhaul, or like what was going on there? Is that a problem we're still seeing? Prospect Heights too. I remember early pandemic, Prospect Heights was like, uh-oh, there's so many people on there.
It's both. I think so. For each of them is a different case. So now we're getting a little bit away from the backhaul. This is more like backhaul and like what the node links to the nodes and apartment buildings and stuff. At Saratoga, when I first joined the mesh, was the link to a VPN, so like a box. And that was a major problem. So once we got Vernon, that alleviated, that like doubled everyone's immediately. It also means when you double everyone's speed, it means that now everyone is also sharing that internet manage have issues as well. In a local sense. I think it's okay. We've added sectors to both that have sort of split up the load. Starry seems to have the interference has gone down significantly since a few months ago, which was a big thing. We were seeing new starries come up all over, and frankly, now they've actually disappeared.
You want to give more context on that?
No, as I'm sorry, and then, yeah, so that's been helpful, but yeah, backhaul upgrades has been significant, and especially for Saratoga, Vernon, yeah, improving the backhaul is sort of big for everyone. Obviously, there's going to be bits and pieces of problems. This is how these yeah.
I think there's an interesting thing here that Rob brought up, and this I sort of brought up a little bit earlier, which is that what is the next thing that we can sort of solve after backhaul is solved? And as you just said, once you increase the backhaul, now the access to the user is faster, if you will, which means that we notice the contention on our sector antennas that have 30 people already going to them, right? So I think that's the next, seems like that's going to be the next big problem is what you just mentioned, right? Overloaded nodes that kind of were okay for a while, or they were bad, they got okay, and now they're probably going to increase as people start to do installations and you get 40, 50 people on a PT. So I think we might need to put some conscious thought into that.
I mean, maybe using sort of the same not connect or
Can
isolated.
you see if you can join that Google Meet? Do you have that link?
And bridge from one connected to it over top of it using a separate antenna on the other side, so they could bypass.
Okay, I have an idea.
So the issue with the sector question, that is the actual more challenging part. And that one's going to be definitely more reliant on how tall your
No,
building is,
the
on
Meet.
how
Do you have the
many
Meet?
physical houses you can see when you're looking to it. It's not just a matter of can I see 2 nodes or repeater. If you want to repeat for a neighborhood, you better hope that your 8-story building can see all the way. So now that means
Carter?
So we just break out into groups and I go some beer. Maybe less technical discussions can be over here and more technical discussions can be over there.
Okay. Sorry for everyone about that stream. My camera died halfway through. We don't have our usual streaming technician tonight, so I pulled this together in about 5 minutes before I left my house. Apologies about that, but we did our best.
Lyden did a great job. Thank you all for being on.
Thank you, everyone. Have a nice night.